So the thing that I'm going to like talk to you about is like HTML5 performance stuff. There's a ton of different presentations on the web about the same thing, and actually quite many of them are actually quite good. So I think like this is going to be sort of like a wrap up of the things that I have found useful. I'm trying to share some of the tips that I have like found useful, and if there's something that we can like discuss a little bit more about, we could like even sketch a little bit. I got like fancy new toy for that. But probably from my viewpoint and from the SC5's viewpoint is that, okay, the reason why we are talking about performance is living up to this dream that, okay, one day like HTML5 application would be able to kind of challenge native applications in performance. Or actually not necessarily in the performance, but in terms of user experience. But if you have been reading stuff over the internet, they have said that like good, like well-performing web applications translate quite well to better user experience. People are like used to using kind of like slow applications. So one of the challenge has been actually the same thing that I'm trying to pinpoint here in this slide. So you know, okay, we have been doing web application for what, like 20 years already, and we have like learned a particular trend on making web applications. And let's put it that way, that okay, web application developer culture is not kind of like performance-oriented culture, not in the same way as we have for mobile applications. In the mobile applications, like the resources have always been scarce, and you have like tiny display, you have like slow processor, quite little memory, all that stuff. Whereas in the web applications, you know, like today's desktop computers, they're pretty good. So now when we're talking about the HTML5 applications and their like performance, what we are talking about, like to be able to kind of jump from this normal like web developer curve in terms of like pretty okay user experience to do the application level user experience, and that takes a good performance. So getting a little bit more about the background. So how many of you actually have been browsing these HTTP archive graphs that Steve Souders has been posting for, I don't know, quite many years already? Okay, if not, I like warmly recommend you to kind of like check those. There's like, actually I have like a couple of copies over here, but let's check. But anyway, the point is that, okay, this is actually a graph for like from the past 3 years. And okay, within like the 3 years, okay, we have already got like a kind of like 500K of like extra, well, okay, from my viewpoint, like extra crap to our like web pages. Today, like an average web page, when you like load it, it actually like loads like 1.5 megabytes of resources, which is actually quite a lot. And on average, it like does something like 90 plus, maybe like quite close to like 100 requests per second, and not requests per second, but I mean like requests to the server, which is actually quite a lot. So in that, like from that perspective, it is quite understandable that the web applications are not like performing that well. What you can also read is that, okay, the trend is still upwards. So probably, I don't know, in the next, I don't know, 2015, our web pages are probably going to weigh like 2 megabytes and probably have like 120 requests and something like that. So the trend is still like tending upwards. So that means that, okay, even if we have been talking about web performance for quite a long time already, from this trend viewpoint, it seems that we are not learning anything. And actually, you can like see it from the other curves as well. Here you can see, okay, like where this like extra fat comes from. So you can see like what is the curve that like tends like most strongly upwards. It's like definitely like these images, both not necessarily the number of images, but like how big they are. So currently, like today, probably I don't know, more than half of the size of a web page, or what I mean, okay, when you're like downloading a web page, is images. And you can see on the like lower left hand corner that actually, as it comes to like Google's like performance measurements in page speed, like these web pages are getting like slightly worse. Otherwise, it seems the thing had been like quite stable. So okay, we are not necessarily having like that many more elements in our like document object model. they're like still way too big, kind of like 1,000 elements. Okay, and the document size is like around 30K. So it's not the web page, it's all the resources that it loads. But from the other viewpoint, this is actually what I had in the like synopsis of my presentation that I quite like boldly put over there that, how to say, like the web browsers are like much, how to say, like much more powerful than you are in like wasting their resources. That is not like necessarily fully true, but if you really try to put like things into context, let's say that, okay, we know like an average web page like weighs 1,000 DOM elements. Depending on how you use these like DOM elements, you could say that, okay, that could be like roughly, I don't know, close to like 1,000 native widgets on your mobile application. Or say that, okay, like, okay, web pages, they like load 1 megabyte of images, and they like load most of that over the wire. Whereas in the mobile application, most of that is like stored in your local disk. So if you basically try to kind of like measure like web pages or like web application in this context, it's quite obvious that like a mobile application, if they were constructed in the same way, they probably wouldn't perform that well either. But okay, there's like some like bright sides to the web pages. So like currently we're targeting that like web page would load in one second, whereas how many applications you have installed that install in 1 second? But probably like other like important thing, like why we're talking about this, is the kind of like the increase of mobile use within web applications. So yeah, I try to put things into my own like personal context. So like the computer that I'm using today or a couple of years back, it's like a pretty powerful machine. It's quite obvious that I won't be able to waste all of its resources. But let's say like even like quite like modern phone is still crappier than my current computer is. Let's say that, okay, it might be, yeah, might be like comparable to the computer that I used in like 2007 or 2006. But in some, by like some measures, say, for instance, like display, how to say, like total of pixels in display, or like what kind of connection I'm using, it actually might be like back to the 2003. So that means like pretty slow computer, or at least slow connection. So the point over there is that, okay, we should start like creating web applications the same way as mobile applications are. And what I mean by that is that, okay, we should be kind of like performance aware from the very beginning. And these readings that you see over here, and this, how to say, like a little bit like mixing results from the like psychology and then, okay, hardware stuff. So basically it's like this 1 second application startup time. That probably would be kind of like a plausible or like reasonable like expectation for like application startup time, or like some kind of like application, like the time by which like the application really should do its job. That actually comes from the fact that like person's like attention span is something like around like 1 second. So basically, if your application loads for like several seconds, your user's already thinking about something else. There's a question.
Has this changed? Latest I've heard, the research says that 5 seconds is enough.
Okay, it's probably like a different source from that. I don't know, this is like the source that, probably like all the studies that I have seen are actually quoting the same original study. I think like this is like back from the 90s. Yeah, so I don't know.
5 seconds is after that the users will try to do something if the UI doesn't do that.
Okay, I'm actually also like repeating like that point over there. So basically, okay, like by like other measures, the 5 seconds actually might be more like plausible target. Let's put it this way. I would actually assume that if we think about like the user of today, I wouldn't assume that their like attention span would have at least grown. Probably have like become like much more kind of how to say, like lose our like interest much easier. So of course, then if we go to like some other measures that might be a little bit like easier. So let's say that, okay, we as humans, okay, we are able to like notice differences that would go like faster than 10 frames per second. But okay, what we know that you probably can't make like any good sense of those changes. You might be able to see that, okay, you would see that, okay, if you would have like animation that would be changing like 10 frames per second or like say like every 100 milliseconds, you would notice the difference that, okay, this is a little bit clunky. But let's say that, okay, as conscious conscious user, you probably wouldn't be able to tell the whole difference. You would be able to see that something is wrong. So basically, okay, when it comes to like giving some kind of feasible or like a meaningful kind of response from the UI, you would have like around like 100 milliseconds to play with. But of course, when we're talking about something that really like should like look smooth in your vision, then you probably should be targeting, I don't know, what is the limit. Like I have heard like some people have been able to kind of like feel some kind of difference, even if it would be like 100 frames per second. But what we know that the current displays, they are going to like show to like 50 frames per second anyway. So basically, this like a 60 millisecond target for animation should be quite all right. But I believe like this is actually, as a developer, this is like the root cause why we are making crappy application, at least for mobile. So if your computer really is like really powerful, like 20 times as fast as your target device is, of course your application is going to like run slow on the target device. So let's try to kind of get to these limits one by one. So let's go first through the like page loads. This is probably going to be like bulk of my presentation because Kim was going to talk like a whole lot more about the rendering part. So we can try to like put the focus over here. So if we make like a quick breakdown of the 1 second budget, it is actually quite little. So let's say that, okay, if your phone would really start on an idle mode, what it would like first need to do is really kind of turn on the device radio, which is actually quite slow operation. I don't know, it's like 300 milliseconds. At least what I heard from my friend that's actually working on mobile phones, he said it's probably more. But let's say, okay, if we are lucky, we don't waste like a whole second over there. Okay, then okay, you would like when you would like type the URL. Of course, it would need to translate the domain name into like IP address, and of course, the domain name lookup itself would be taking quite a lot of time. Let's say that this 150 milliseconds would be quite positive because in many cases the latency in the 3G network, for instance, would be 150 milliseconds. But basically, like the DNS response would need to travel back, so that's quite optimistic. If you would be like running over SSL, as you would if you were Facebook or even if you would be Google or whatever, the handshake would take quite a lot of time. And then only then after you would have like roughly like a 350 milliseconds left, of which 200 you probably would be using for loading the resources. And that basically means that if you're like running a normal web server, probably you would get your HTML page back in 200 milliseconds. So it's quite little time. And then you would still have like good like 150 milliseconds left for doing all the parsing and layouting and painting. It's tough, especially over 3G. And yeah, we pretty much like already like walked through like where the fat comes from. So you can see that like a normal web page currently, 1 megabyte of images, and like more and more JavaScript. So our like applications have really grown to be like more application-like. And unfortunately, it's not always a good thing. The style sheets are quite small. The Flash is quite small. And the other thing actually, mostly today refers to JSON data. So we are also like downloading quite a lot of that. And then the HTML page. So actually, you don't get much by optimizing your HTML page, or you would, but we could actually get to that point a little bit later. Another kind of quite important remark is that, okay, we are still like downloading our pages over HTTP 1.1. If I remember the original standard correctly, I think it said that you can like make like at most like 2 connections to the same host at the same time. To my understanding, like contemporary browsers are actually not doing that. They are able to like open like up to like 6 connections to the same host. But let's say that, okay, when you start downloading your page and you have constructed your page in a little bit funny way, what it would first start like downloading, it would download the HTML page, and then it would like start to pre-parse and see like what are the other things that it would need to download. And if you have like a ton of different images in the beginning of your page, most likely you would be kind of like stacking all your pipeline with those images. And if you have some like real vital JavaScript, or I don't know, let's say that, okay, your CSS file would have fonts or something like that, it probably means that, okay, those fonts and whatnot, they wouldn't load until the images have got loaded. And if I remember correctly, HTTP 1.1 spec says that these resources should be served in the same order as they have been requested. So if you start by kind of getting your pipeline stuck with some resources that are like dynamically generated and takes like, I don't know, 5 seconds in the server side to generate, most likely that means that, okay, all the other resources would be waiting, and that's naturally a bad thing. I assume that we have some like web developers here in the house, so you probably have seen this like page loading waterfalls. How many of you have like been like seeing something like this? Yeah, all of you. So you probably also can like read them quite well. Let's put it this way: I'm actually still learning, but I always like learn something new when like checking new application. This application that we are currently checking here, it is actually our web shop HTML5 application. And it's not actually the worst application that we have had. We have spent some time optimizing that. But I still like noticed some quite like interesting things over there, and probably like these like interesting things, they differ application by application. But I could basically try to like check like what kind of things we can like read from this one. So I mentioned you this thing in the very beginning, that okay, when you're kind of starting your application, you would download the HTML page, and okay, you actually would have like huge latency over here. We probably have like very slow cable. Yeah, this is actually over a simulated 3G connection, so that probably explains the long latency, and probably our like Node.js server or like the unoptimized version like explains the rest. So okay, then you actually like stack your pipeline with this, like six funny resources, of which actually only one is meaningful. It is the style sheet. But because okay, the preparser has seen that okay, there's like a lot of like images to be downloaded, it downloads all that stuff, and because it downloads these images, then there's like important stuff like okay, the fonts that really would be needed for the rendering, the JavaScript file, which is not actually vital, but which would be like more interesting than the images. Those are waiting, and then you're starting to see like this kind of like a 6 resource chunks when this like downloads like finish, or all of them. Probably like other interesting thing is that, okay, this line over here, it tells you that okay, like now the like DOM content is ready. So basically, okay, the DOM would be ready. If it would have everything, it would be able to render, but it doesn't have the CSS. It doesn't have all the other like vital resources, so it can't render yet. And here you see like really the mark that okay, now the page has got. That is like when the page is sending like on load event. So actually then like the JavaScript and that kind of stuff can start executing. But the interesting like other like interesting remark over here is that we have like all this crap over here because there's actually like one or there's like a few like fancy carousel images that for some reason the engine has thought that okay, it really needs those prior it can paint the page. I don't know why, but it basically what I can read from the image is there's actually quite a lot of crap over there. And of course, like those waterfalls will depend quite a lot on like which kind of like connection you're simulating. But the good thing is like usually like simulating connections on your computer is quite easy, or at least if you are Apple user. There are also like tools for Windows, and probably if you're like Linux hacker, you also know like how to configure your firewall. How many of you are already using this network link conditioner? Only a few. We will like check shortly how to use that. But this is actually quite like easy to use and interesting tool that you can use for like simulating different kind of connections. Unfortunately, it also only like works for this kind of like external, how to say, if you like connect to some like other computer, you can't use that for localhost. But if you basically want to like debug your own like host that is I mean, if you have like if you want to like debug your service that you're currently developing on your local host, then you can of course like use a script. If you don't want to write your like own like firewall script, there's actually a link that you can use for yourself. It's like very short snippet for restricting how much you can load and generating a little bit of errors and that sort of stuff. But we will check like network link condition shortly. The other good everyday tool is like webpagetest.org. How many of you have been using this one? Yeah, you really should, because it's like even easier. So basically, you probably have been using the, like Google's PageSpeed because it's available in your own browser. Pretty much webpagetest.org, it gathers same metrics, but the good thing is that okay, you can like simulate a different connection, for instance, from a different country. So you could get kind of like quite good understanding on how your users in, say, I don't know, Germany or Russia or like wherever, how they would like perceive your application. And then it can actually like give you like different kind of grades on how well your application scores. So for instance, okay, this application, I think this is actually this is like the same, it's like SC5 by example. You probably may remember that there was like very long latency. So it's quite like rightful that it actually got like a failure for the first byte time. Otherwise, actually, it was scored quite all right, but probably the images, they could have been progressive. I know CDN was in use. So basically, like even if it was like slightly optimized, and some of the best practices was still failing. This is a little bit like newer thing, and actually, I only included it for the reason that I'm so excited about that. I started playing with that last week. And how many of you have been using mod PageSpeed or like Nginx's version of that? Only a couple. Okay, you will see it shortly because I have been using that. I also like made a kind of Docker image. Docker is kind of a easy like way of setting up your own like virtual machines. So so there's like ready-made recipe for you if you like. But let's actually try to like put some of these things into practice. Or actually, even like before like putting into practice, we could actually check like what are the different things that we could do. So this is like my own like prioritized list of what we should do and which kind of order. So basically, let's take like easy wins first. So basically, like turning on HTTP 1.1, and of course, it's like keep alive option. It's like just like one single switch in your Apache or like Nginx configuration. It's probably on by default already, but if it isn't, you should really turn it on, because it probably would, well, you would get the keep alive feature, which means that, okay, you would be like creating a lot like fewer like TCP connections, which means that, okay, you would have like a lot less latency. So please do that. And then of course, like really like the next easy win is that, yeah, like use all kind of like caching in all the possible different levels. So like use it on your own application server, use it through the CDNs, whatever. You will gain a lot. And of course, like okay, if you have some users abroad, the latency is like a real killer, especially for the mobile users, because the mobile connections have like a longer latency. But CDN can help on that, so use that one. Then there's like typical ones that we use the one that the customer uses, which unfortunately in quite many cases is none. Which one do you use?
We actually use Edgecast.
Sorry, which one?
Edgecast.
Edgecast, okay.
I used to use Akamai. If you ever need a good one, use that one, but it's expensive as hell.
Yeah, that's what I have heard. Like the customers, actually the few customers that actually, in our case, that care for like CDNs, they are using Akamai as well, but most of those customers are also doing streaming. Probably one of the reasons why like many of our customers are not using CDNs is because they are only operating in Finland, and in that case it's not that important because they can actually get like quite good service running over here.
I would add to that point that in some cases a CDN can hurt your latencies because, for example, if you use CloudFront, which is the obvious choice for a lot of people since it's Amazon product, it will kill your latency. It works properly only in the US.
Yeah, that is true. CloudFront can be a killer. And also what I have heard that actually quite many these like CDN companies, they are like advertising that they have like all the kind of like nifty optimizations and so. And when actually somebody really kind of like reviews and check what they do have, is that okay, they have the computers in like different locations and that's it. Probably you could actually configure like better, how to say, you could probably actually create like quite good CDN by yourself by like deploying a lot of machines on Amazon. It probably would work quite alright. Yeah, but anyway, so then like getting to the point like 4 and 5, so yeah, of course. Okay, the easy gain is that actually like you should actually compress and resize the images. You saw that okay, like probably half of the fat of your web page is in the images. So that's like the first place to optimize because you can easily gain like almost 100% of that. And then of course like build your JavaScript and CSS monolith and like the sprite image and so forth, because then you would have like a lot like fewer connections, which means that okay, you wouldn't be kind of like getting your pipeline stuck with those resources, and it also means that you wouldn't get you wouldn't like make that many connections in overall. And then actually quite a few like other things, but let's try to put those in practice. So I mentioned to you that I'm currently quite excited about mod PageSpeed, and like mod PageSpeed is a quite interesting beast in a sense that it actually can do some of these optimizations for me. So this is actually the thing that I'm talking about. So basically, if you check like the list of like what kind of like optimization it can do for your web page, there's actually quite a lot of. So I was telling that yeah, you should like combine all your CSS into one file. You should like minimize those. All of those are like available in the PageSpeed thing. Okay, you don't like need to like care of your like own like application service cache if your like mod PageSpeed modified Nginx does that for you. You can do a lot of different kind of things. And let's actually try like put that, like make an application of that. We in SC5 we are making so many Java like applications that are heavy for JavaScript that they are actually quite difficult to optimize. So and they're like partially optimized already. So I couldn't like get a good sample from our sites. That doesn't necessarily mean that they're optimal, but they might be quite good in some regards. So I tried to like find some like different sites in Finland, and this was actually like the first one that I got from Google. But when I tried to download it, it actually caught my interest. So probably the first thing that I saw over there is that actually, let's say, even if I would be simulating a Nexus 4, mainly like mobile device, I would be downloading like more than 2 megabytes of stuff, which is a little bit too much. And what I also like found from the website is actually there are like so many different kind of resources that have been like haven't been minimized. They haven't been squashed into one. They apply no caching. You can actually see the same from the webpagetest.org. So if you type over here, let's say somebody from Germany would be visiting Finland or would be interested on that. And he would be doing it over Chrome and 3G connection. So that actually could be like quite close to this particular setup. He would get some like quite like lousy results, but it's computing, so let's get back to that a little bit later. So the point is, what we see over here is that like the downloading actually didn't like take that much time on my good connection. As you can see, basically, okay, it gets like rendered in like less than 2 seconds, but things actually turn quite different when you are using network link conditioner. So let's like turn it on. Come on, here. So this is actually a tool that is actually Xcode add-on. So you first would need to download Xcode, and then you would be able to download this one. But it's available for free, and it's quite easy to use. So I turn it on, and let's say that we would be simulating 3G average case. So now I think we would have a setup that would be, let's say, it doesn't match your phone. It's not real like Nexus 4, but it has a connection that's comparable. It has a like display that is sort of comparable. It's not the real thing, but it's, let's say, good enough for your everyday development. Then you should probably do the testing separately. So for this one, things are actually a little bit more sluggish. Let's actually do it this way first. About blank or whatever. I wanted to start from like blank page, and I have turned on, let's see, yeah. So I don't have like any in the cache. So you can see here when the like waterfall starts to form, and it's already 6 seconds, then we get a like blank page, and then we start to see something. So what you can see from here is that, okay, the DOM content got like ready in like 10 seconds or so, and we were like ready to render, and actually the like on-page load hasn't still fired. Okay, now it did. So by some metrics, it's like pretty slow application. Let's see what is the problem on this one. So when you start by start time, you can see that actual resources are like downloading in quite reasonable order. You just have like a bunch of CSSs. That's what you would need first anyway. And actually then you have like some JavaScripts. You actually don't necessarily need those. Depends on the application. And then you have like a lot of images. And that's it. So let's see if we can optimize this with page speed. So I'm actually cheating a little bit over here because I have the Nginx and the PageSpeed running in my own local computer. So it's not actually a real simulation of, how would I say, having a reverse proxy somewhere else, but it's like good enough for the development. So let's see. So what I have here is actually Nginx configuration. The Nginx has been compiled with mod PageSpeed support built in. What else I have here is a little bit like Nginx setup. And then like important point over here is this like different filters that we're having. So what I'm saying over here is that, okay, let's like act as a cache for the original service. Let's like shorten its URLs, just that it would be like easy to cache. Let's modify the CSS. Let's write a sprite sheet. Then probably the important part comes. So basically what we can do is like move the like critical CSS inlined as part of the web page. And then we can say that, okay, don't actually clutter the pipeline with images, load them after everything else. And then I said, okay, don't actually clutter the pipeline with JavaScript, load that when the page is about to load. And then like a little bit like page speed configuration of telling that, okay, our like localhost port like 59080 should be mapped into visitfinland.com. And that's pretty much it. So now I would be, yeah, we can actually check that one a little bit later. FINHTML5 So the important thing is that when you're like starting this like mod page speed for the first time, it actually hasn't cached anything, so it's probably as sluggish or like more sluggish because like extra proxy in between. But let's say like we're emulating Nexus 4 and then like download the page from scratch. So what you can see if you're like very quick in your look, that okay, you can actually count in your mind that okay, now it started to download and actually like most of the stuff got visible quite quickly. So the interesting point is that like what the mod page speed actually did for you is that it actually like moved some of the, well, first of all, it actually did a little bit of like magic for all the CSS files. It wasn't able to compress those that much. But as you saw, this like DOM content loaded like event, it actually triggered almost instantly. Actually, the reason was that when you were like checking from here, probably the resource that was blocking the things, I can't like find from here, but most likely that was a JavaScript file. So the point was that, okay, with mod page speed, I was saying, okay, defer the JavaScript execution, and you got it. How to say? Then it was like no longer like blocking you. And the other like important thing that it did, it actually probably did inline some of your CSS code. Let's see. Come on. Where do we have the CSS? Okay, we got like at least like something inlined, but actually these are like mostly Facebook stuff. It's actually interesting that it started like inlining that. Yeah, but really, probably like most important part about this mod page speed is that it's like easy to play with. If you have an like existing website, you can like easily set this as a like reverse proxy. See that if some of these like dirty tricks, if they apply for you, basically, okay, if you can basically like squash your CSS, if you can basically like save on the number of resources loaded by like creating sprites, that sort of stuff, it's quite easy. And then actually the like other thing that got loaded, so it's like web page test. So it actually gave quite the bad results for the Visit Finland. So almost like failure in everything. And you can also like see from the like waterfalls that there's some resources that take a really long time to load. And the good thing is that you can also like check kind of like film strip view. It can actually show you like how what the page like looked over the time. So basically for the first 3 seconds it was like blank page. Then you actually start to get quite feasible stuff, and you actually got the same feasible stuff for like 10.5 seconds. Yeah. But probably like the most, how would I say, probably the best resource that I could like recommend to you on kind of like checking like page loading time is the book by Ilya Grigorik. He's I think like some kind of performance engineer in Google. Let's see if I can like easily skip over there. Yeah, this one. So basically this book actually like gets like into quite low level. So it goes like all the way to kind of optimizing your SSL and actually optimizing the Linux kernel on like making like web pages load faster. It's actually a very good resource. And the best thing is that it is available as a free book. So basically kind of like the price won't be an issue for you. So you can actually like download it from this site automatically. Good. But hey, I have been using for my 1 hour. Probably like remaining part that would be left would be about the web page kind of rendering performance, but probably like Kimmo would be like much better source to tell about that. Do you have any questions?
One question. So I think you could use quite a bit of time or resources when the user is not doing anything. Preload items. So for example, if you remember image-ready JavaScript for mouse overs and such. So I think that's something that if you have 3 steps, for example, in your application, you enter the first step, you could already start doing stuff for the second step.
Yeah, actually funny that you mentioned, it's like part of the presentation that I didn't cover, but let's see if it's the same thing that we were talking about. Or did I actually skip to some specific slide? It's quite obvious that I'm still not like managerial enough if I can't like easily skip the slides. Yeah, so basically, okay, this is how you would like do it in normal case. Just like load things, and those would like trigger something else. And in normal case, you basically click something, then it like loads a new page. So what you could do is do some trigger to buy a little bit of extra time. So the most obvious one is okay, to get to this like 100 millisecond feedback interval, you would basically show some like loader. And then like what you were talking about, okay, we could start like preloading the next page, for instance. But this is actually a little bit like double-edged sword because, for instance, for like mobile users, let's say that, okay, we can't actually guess if they are, for instance, like using the mobile page over roaming or something like that. So in that sense, it actually might make more sense to kind of like leave it to the user. But of course, if you are like very if you know the kind of usage pattern of your web page or like web application really well, then you actually might be able to save something. But we also like need to remember that actually browsers also are doing a lot of guessing on this one. Kim, actually, have you been playing with this? You know, like Chrome has this whatever predictor. Yeah, this predictor class. It's actually making quite a lot of guesses for you. It's, for instance, like doing like DNS prefetching, and I think like nowadays it's probably not preloading the links, but I think at some point it was.
Yeah, you can add some meta tags, like what to load. And so to get one thing, obviously here in Finland most of the mobile subscription is still unlimited data, but if you really need to save up on data usage, then obviously it doesn't make sense, depends on.
Yeah, absolutely. And probably like how to say, you can do like some trigger with JavaScript, especially for like all the like dynamic data that you're loading. But there's probably also like a better way. HTML, there are like emerging standards on kind of like annotating some of your links with this like prefetching attributes. So I remember that there was probably something that you could like do to like you could basically like prefetch pages, and then there's also like possibility in your HTML header section to say that you could do some like DNS prefetching. So for instance, if you're like loading your images from some CDN or whatsoever, you would need to do extra DNS lookup, but you could already kind of like hint the browser when it's passing the header section that actually you will need those later on, so do the prefetch. So I would like recommend using those, but of course that wouldn't apply to, let's say, IE8. It would only apply for the kind of the current Edge browsers. But that's interesting stuff indeed.